here we're going to consider integration as the reverse of differentiation. Consider that if y is equal to 2x cubed, then you should know that dy dx is equal to 6x squared. Since integration is the reverse process to differentiation, it follows that if we integrated 6x squared, we'd get 2x cubed plus an arbitrary constant. The reason for the arbitrary constant c is that had we differentiated y equals 2x cubed plus any number, we would have obtained dy dx is 6x squared, since when we differentiate a number, we get 0. So differentiating y is 2x cubed gives us dy dx is 6x squared, and differentiating y equals 2x cubed plus a number also gives us 6x squared, because the number disappears when we differentiate. That's the reason for this arbitrary constant when we integrate. So to recap, the constant c acknowledges that reversing the process could give us 2x cubed plus any number. The general formula for integrating functions of the form ax to the power n is that the integral of a times x to the power n with respect to x is a times x to the power n plus 1 divided by n plus 1 plus a constant. I always think of this as increase the power by 1, so from n to n plus 1, divide by the new power. The new power is n plus 1, and you can see we divide by it. For example, if we have 5x to the power 6, you can see we have 5x to the power 7, increasing the power from 6 to 7, divided by the new power. And don't forget to add the arbitrary constant. This works for negative indices, except for -1. X to the minus 1 follows a different pattern, which you'll meet later. The integral of 3x to the minus 4 is 3x to the minus 3, minus 4 add 1 is minus 3, divide by the new power, and tidy to give minus x to the minus 3 plus a constant. It also works for fractional indices. The integral of 10x to the power 2/3, increasing 2/3 by 1 gives us 5/3. So we get 10x to the 5/3 divided by the new power. If we divide by a fraction, we turn upside down and multiply. Therefore, this tidies to give us 6x to the power 5/3 plus the constant. Remember, when dividing by a fraction, as we mentioned, we turn the divisor, in this case the 5/3, upside down and multiply. When integrating a constant, just a number, remember that, for example, 7 could be written as 7 times x to the power 0. Remember that x to the power 0 is 1. This gives us the integral of 7 would be the integral of 7x to the power 0, increase the power by 1 and divide by the new power, so we get 7x. So if we integrate any number, we just get that number times x. If we have an expression consisting of several terms, we integrate term by term. Suppose we have the integral of 8x cubed minus 6x squared plus 10x. Take away 5. And remember, x here is x to the power 1. For the 8x cubed, we increase the power to 4 and divide by the new power. The squared here increase the power, divide by the new power. This is 10x to the power 1, increase the power to 2, and divide by the new power. And of course the number 5, as previously discussed, becomes 5x. Tidying this gives us 2x to the power 4 minus 2x cubed plus 5x squared minus 5x plus a constant.